In this video, I will give an overview of the robotics research activities that TU Delft is executing in collaboration with Ahold Delhaize in our AI for Retail Lab Delft. We have been promised to be able to use robots anywhere for any task, specifically for dull, dangerous and dirty tasks. And this promise already stands for decades. Yet if you look around, you don't see robots anywhere. They're not in our homes, not in the fields, not in the supermarket. So what is so difficult in robotics? The key challenge in robotics is to deal with variability. For robots, their work becomes difficult if there is variability in objects, such as the endless products to handle in a store. I mean, if you look closely, even each individual fruit has a different shape. Then there's variability in the tasks that robots must execute, and a wide variability in how to interact with people. Finally, there's variability in the environment, and this actually entails many things. Obstacles that the robot must avoid, variations in the ground that is driving over, varying lighting conditions, which make the robot images look very different, variations in sound, and many more things that all can vary and all make the robot's work difficult. While researching this, we become more and more impressed by the capabilities of humans to handle all of these variations. So this is the reason why we don't see so many robots yet for these applications. Now, we do see highly successful robot implementations in environments with low variability, such as the car factories. Out of all of the variability challenges to make robots successful anywhere, together with Ahold Delhaize we have identified 3 robotic challenges to focus on that are mutually interesting. First, we focus on the variability in the motion that need to be executed by a shelf restocking robot. Imagine that a robot needs to restock the bananas. How should it structure its tasks? How should it move? And how can it learn to handle the wide variety in shapes of objects, in this example, bananas? Second, we research the vehicle routing problem for same-day delivery. Now, even though the vehicles are not necessarily robots themselves, their routing problem is still a highly challenging robotics research problem, due to the enormous variability in orders, routes and timings. And third, we research the ethics for the implementation of new robots in and around stores, how to handle issues with privacy, security, customer experiences, employee satisfaction, and many other human values which sometimes even conflict with each other. While we focus on these long-term research issues, the route to success for more immediate robotic implementation consists, I think, of 3 things. First, I think it is useful to stimulate the researchers with challenging problems, yet leave them free to explore what to research. Sometimes practical challenges, like routing problems, lead to fundamental breakthroughs in generic mathematical optimization problems. Second, variability is the main source of difficulty, so you want to reduce the variability for initial limited scope implementations in your own stores or warehouses. And third, to make sure that all stakeholders are involved, it's also important to manage the expectations. We should not overpromise short-term possibilities. By the way, expectation management also extends into the actual design of the robot. For example, for a restocking robot, which robot do you think is better? Robot A or Robot B? Assuming that they have the same cost and the same shelf restocking capabilities. Well, the human-like design of Robot A creates the expectation that it can think and act like a human. Now, since its artificial intelligence is nowhere near human thinking, this design clearly gives the wrong expectation. So Robot B is by far the better choice. Talking about expectation management. So, let's go for ubiquitous, helpful robots in our stores and anywhere else by solving the great variability challenges for robotics.